In this scenario, we're flipping a coin twice. So we're going to start by just looking at the outcomes we get when we flip a coin twice. So we can use a tree diagram to do this, just a basic tree diagram. And we should know we have 4 outcomes. You can think about there's 2 outcomes for the first flip times 2 outcomes for the second flip, which is 4 outcomes. You can also see those outcomes in the tree diagram. If we list out those outcomes, the first outcome, if you follow the branches, is heads, heads. The second outcome is heads, tails, tails, heads, and tails, tails. So those are our 4 outcomes. Let's also look at the probability. In this case, there's a couple ways to think about the probability. Since the outcomes are equally likely here, flipping a coin, you're equally likely to get heads and tails. It means you're probably getting heads, heads is 1 out of 4, because there's 4 possible outcomes, heads, heads being one of those. You can also always think about this in terms of multiplication rule. The probability of getting heads on the first flip is 1/2 times the probability of getting heads on the second flip is 1/2. 1/2 times 1/2 gives us 1/4. So in this case, the outcomes are equally likely, like we said, so they're all 1/4. So that's not the probability distribution for x, but that's just the experiment of flipping a coin twice. To actually write out the probability distribution, we need to list out our x values and list out our probability of x's. The most common way to do this is just to create a couple columns. The x values is the number of times I get tails, so when I flip a coin twice, I can get tails either 0, 1, or 2 times. Then we can look at the probabilities. The probability of getting tails 0 times happens one way. And we already said that that probability is 1/4. Probability of getting tails 1 time can happen 2 different ways, each of those probabilities being 1/4, making this total probability 1/2. And then finally, the probability of getting tails twice happens one way out of the 4, which is 1/4. So this is the most common way to write a probability distribution, and that's how you'll typically see it in this class. A couple things to notice. This is a discrete variable. The outcomes are 0, 1, and 2. All the probabilities are between 0 and 1, and if you add up the probabilities, they sum to be equal to 1. That's an important thing or characteristic that every discrete probability distribution will have. And it never hurts to check that. Just make sure your probabilities sum to 1. Another way, kind of variation of how to write this, is sometimes instead of writing probability of x, you'll say the probability of 0, which means the probability x equals 0. We just said that's 1/4. Probability that x equals 1 is 1/2. And the probability that x equals 2 is 1/4. So this is an alternate way to write a probability distribution. Not as common as the first one, but I did just want to mention it.